Welcome to Master Mathematics in Minutes. Today's topic is about factorization by grouping, and we'll cover a couple of examples on how to apply the grouped factorization, and we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is factorization by grouping? We can factorize an expression by grouping terms together. Consider the example where we have ax plus bx plus kay plus kby. We can group the terms containing x together, as well as the terms containing ky together. And then we can factorize x from the first two terms, and that becomes x into a plus b. And for the third and fourth term, we can factorize k and y, and that becomes ky into a plus b. And notice that with a plus b and a plus b in both the two terms on the right hand side, and we can further factorize that a plus b out, and that becomes x plus ky into a plus b. Let's consider a couple of examples now. In the first example, we're asked to factorize the expression mx plus nx plus 5my plus 5ny. So, we can group terms containing x together, and we can group terms containing 5y together. So we can factorize x outside, and that becomes x into m plus n on the first two terms. And for the third and fourth term, we can factorize 5y out, and that becomes 5y into m plus n. And notice that m plus n are common terms as well, so we can factorize m plus n out further, and that becomes x plus 5y into m plus n. In the second example, we're asked to factorize the expression 8x plus 4 plus 2xy plus y. So, we can group terms containing the same variables together. So we'll group the third and fourth term with y's together, and we'll group 8x plus 4 together because they are multiples of 4. So we can factorize 4 outside of the brackets. That becomes 4 into 2x plus 1, and we'll factorize y out of the third and fourth terms, and that becomes y into 2x plus 1. And once again, notice that 2x plus 1 are common terms on the right hand side. And so we can factorize that out further, and that becomes 4 plus y into 2x plus 1. In the third example, we're asked to factorize the expression 7p squared plus 7pq plus q squared plus pq. So once again, we can group terms together. So we have the term 7p and 7p together as the first two terms, and the terms containing q together. So we can factorize 7p as a common term out from the first two terms, and that becomes 7p into p plus q. And similarly, we can factorize q out of the third and fourth terms, and that becomes q into q plus p. And notice that with the common terms p plus q, and so we can factorize that further, that becomes 7p plus q into p plus q. In the fourth example, we're asked to factorize the expression st plus 5t plus s squared plus 5s. So, we can recognize the common variable in the first two terms as t, and with the common variables s in the third and fourth term. So we can factorize t from the first two terms, and that becomes t into s plus 5. And similarly, we can factorize s from the third and fourth terms, and that becomes s into s plus 5. And once again, we have s plus 5 as a common term, and we can factorize this expression further, and that becomes t plus s into s plus 5. To summarize, we can factorize an expression by grouping terms together. So we've seen the example ax plus bx plus kay plus kby. We have the common variable x in the first two terms and the common variable ky in the third and fourth terms. So we can factorize x from the first two terms, and that becomes x into a plus b, and we can factorize ky from the third and fourth terms, and that becomes ky into a plus b. And notice that a plus b is the common term on the right-hand side, and we can factorize this expression further, and that becomes x plus ky into a plus b. Thank you very much for watching. This is Master Mathematics in Minutes.